Hello students, in this video we are going to learn about binomial theorem. Um, let's start with, let's say, combinations. You might have learned about permutations and combinations. Let's start with combination. Let us give an example. Let's say there are five different textbooks: physics, chemistry, math, history, and geography. Okay, so if there are five different textbooks, in how many ways can you take one textbook at a time? Okay, so maybe you can take a physics textbook, or you can take a chemistry, or you can take a math, or you can take history textbook, or you can take a geography textbook. So basically there are five ways, isn't it? So I write it as 5C1 equal to 5. Now this 5C1 means, this 1 means you're taking one book at a time. This 5 means there are 5 textbooks available. C means the combination. Okay, combination. That means there are 5 different combinations in which you can take one book at a time out of 5 books. Okay. Um, Let us take 4 textbooks. Let's say physics, chemistry, biology, and math. Again, in how many ways can you take one book at a time? 4, isn't it? Either you can take a physics book, or you can take a chemistry, or you can take biology, or you can take math. So I can write it as 4C1 equal to 4. Okay, let us see how many ways are there in which you can take 2 books at a time. Okay, let's say you can take physics and chemistry, or you can take physics and biology, or you can take physics and math, or you can take chemistry and biology, or you can take chemistry and math, or you can take biology and math, isn't it, students? So there are 6 ways of doing it. Don't P and C and P are basically both of them are same. There is no difference in that. Okay, so there are 6 different ways in which you can take 2 books at a time out of 4 books. So I write it as 4C2 equal to 6. Okay. What about 3 books at a time? You have 4 books, 4 different textbooks. How many ways can you take 3 books at a time? How many combinations are possible? You can take, let's say, physics, chemistry, and biology, or you can take physics, chemistry, and math, or you can take chemistry, biology, and math. Okay. Is there any other possibility? Yeah, physics, biology, and math. So there are 4 ways. So how do you write it? I write 4C3 equal to 4. Right? Good. What about taking 4 books at a time? What about taking 4 books at a time? Then you take all four books, that is physics, chemistry, biology, and math. So there is only one way. So I write it as 4C4 equal to 1. Right? So you found it. Okay. Now you might wonder, can we actually find 4C5, students? Is it possible? Definitely not, because here you can't take 5 books out of 4 books, isn't it? So this is not possible. Okay. And also, can we find, let's say, can we find 4C minus 3? Now again, what do you mean by taking minus 3 books? It doesn't make a sense, isn't it? So that's also not possible. Can we have, let's say, 4C 1.5? Again, that doesn't make sense at all. What do you mean by taking 1.5 books out of 4 books? Not possible. Okay, can you have 3.2 C1? It's like saying taking 1 book out of 3.2 textbooks. No, again, not feasible, right? So let me erase this. Okay, from this we understand, we talk about, let's say, N, C, R. Okay, so this represents number of things available. This R represents, okay, how many of them I'm taking at a time, like I'm taking 5 at a time or 4 at a time, like that. And C represents the combination. And you can safely say that N has to be a natural number. N has to be a natural number. That means N can take only the following values: 1, 2, 3, 4, 5, 6, the counting numbers. Yeah, N cannot be negative, N cannot take decimal numbers, N cannot be fractions. Now what about R? Again, R is actually whole numbers. That means R can also take the value of 0, but again R is positive. R can take 0, 1, 2, 3, 4, like that. Okay, and definitely R has to be less than or equal to N. Again, it is very, very important. R has to be less than or equal to N. So I now just now mentioned that R can take the value of 0. So what does it mean? What do you mean by, let's say, 4C0? Let's say I want to find what is 4C0 means. It means, let us take the same example that I have been using till now. There are 4 books, and 0 means the number of books you're taking at a time. There are 4 books. In how many ways can you take 0 books at a time? That means in how many ways you do not take any book. I would say there is only one way: don't take any book. Okay, there is one way of not taking any books out of 4 books. That is, that way is don't take it. Don't take the textbook. So 4C0 is actually 1. Okay, fine. Let's say I want to find 10C2. Let's say I want to find 10C2. Now, how will you find it? Do you write, like, say, for example, like 10 different numbers, 10 different, let's say, things, and then taking 2 at a time, like I did earlier, like manually? No, that is not feasible, isn't it? So we need to have a formula. Okay, so we do have a formula to find the answer. So what we do is, before that, let me explain about the factorial. Now, R factorial can be written as R into R minus 1 into R minus 2 into 3 into 2 into 1. So what it means is, if I say 4 factorial is 4 times 3 times 2 times 1. So basically this is nothing but 24. So when I say 3 factorial, it's nothing but 3 into 2 into 1, which is equal to 6. So when I say 5 factorial, 5 into 4 into 3 into 2 into 1, which is 5 factorial. Sorry, 5 factorial, which basically means 120. Yeah, and 2 factorial is nothing but 2 into 1, equal to 2. 1 factorial is 1, and 0 factorial is also defined as 1. Now from this, what we understand is 4 factorial means the product of first 4 natural numbers. 3 factorial means the product of first 3 natural numbers. 5 factorial means the product of first 5 natural numbers. 2 factorial, the product of first 2 natural numbers. So R factorial means the product of the first R natural numbers. Now definitely this R, you can see here, R has to be a natural number. So a whole number. That means it can be 0 or 1 or 2 or 3 or 4, like that. It cannot be negative. It cannot take decimal values, right? So this is clear. Now the formula. The formula to find NCR is NCR equal to N factorial by R factorial multiplied with N minus R factorial. Now this is the formula. Now let us write down the values that we got. Let's say we got 4C1 as 4. We got 4C2 as 6. We got 4C3 as 4. We got 4C4 as 1. And we got 4C0 also as 1. So let me cross check whether I'm right. So let me find 4 C1. So this is n and this is r. So if I use the formula, I'll get 4 factorial divided by 1 factorial into 4 minus 1 factorial. So I'll get 4 factorial 4 into 3 into 2 into 1 divided by 1 factorial is 1, and this will become 3 factorial. 4 minus 1 is 3, so 3 into 2 into 1, I get 4. I get this 4, isn't it? So that's correct. So let me try one more. Let me find 4C2 now. 4C2. So I get n is 4, so 4 factorial by r is 2, so 2 factorial multiplied with 4 minus 2 factorial. So again 4 factorial means 4 into 3 into 2 into 1 divided by 2 factorial is 2. Again 4 minus 2 factorial is 2. So I get 6 as the answer. Right? So as you can see, it is correct. So we can use this formula. So please remember this formula. NCR is n factorial by r factorial multiply n factorial by r factorial multiplied with n minus r factorial. Okay. But there is an easy method which I'm going to teach you right now. Without using, we are actually using it, but we don't use it explicitly. Okay. Let me show it to you how we. For example, let us say I want to find 10. I want to find 10 C2. Then what I do is, you can see there is 2 here, that means 2 numbers. So numerator will have 2 numbers. The first number will definitely be 10 because 10 is here. First number will be definitely 10. Second number will be 1 less than 10, which is 9. Done. Denominator, again 2 is given, so 2 factorial, which is 1 into 2. So the answer is 45. So this is how we find it. Let's say if it is 10C3, then there's 3 here, so numerator will have 3 numbers. Definitely it'll start with 10, so 10, and next number will be 9, and third number will be 8, and you will have 3 factorial in the denominator, which is 1 into 2 into 3, right? So you get 3, you get 3, you get 4, so you'll get 120 as the answer. Okay, so let me check. Let's say using this, let me check. Let's say 4C2. 4C2, again 2 is here, that means 2 numbers. So 4 starting with 4 and then ending with 3 by 2 factorial, which is 1 into 2. So we get 6. So that is correct. So let us see more examples. Let's say I want to find 5. Okay, let me take some other example. Let's say I want to find 8C4. So which means 4 is here. That means I should write 4 numbers in the numerator in product. So definitely we should start with 8 because that is what is given. 8. The next number will be 1 less than 8, which is 7, 6, 5. Since 4 is here, denominator should have 1, 2, 3, 4. 1 into 2 into 3 into 4. That is the 4 factorial. You can simplify it and find the answer. Let us take another example. And okay, another thing is, we know 10C1 will always be 10, right? If, for example, NC1 will always be equal to N. Please keep that in mind. NC1 will be equal to N. And same way, NC0 will also be 1. For example, 5C0 will be 1. 6C0 will also be 1. Okay, please keep this in mind. Let's see another example. 12C2 means 12 into 11 divided by 1 into 2. So we'll get 66 as the answer. Then, suppose let's say you want to find 10C2 using your graphic display calculator. You can also do that. So what you need to do is, you know that there are 9 rows of buttons in your calculators. Now in the second row from the top, there is a shift button, a yellow colored button, and next to that there is a button called option, OPTN. You press that, then you will see a list of options in the screen. List, matrices, complex, CPLX, calc, stat, and then you'll see an arrow there which is above F6. So press F6. Again, you'll see 5 options available. One option is called as probability, which is above F3. So press F3. You will get x factorial, NPR, NCR, and RAND. Okay, random. So this NCR is above F3. So when you press F3, I mean when you can type, let's say if you want to find 10C2, type 10 first and then press F3 and then type 2. So you'll get 45 as the answer. So as I mentioned, you can use your calculators as well. Good. Fine. So I hope you're clear about this combination part. First, what do you mean by binomial? We're going to learn about binomial theorem. You know what a theorem means, okay? But what do you mean by a binomial? Now we know about algebraic expressions. Like algebraic expressions are basically it's a combination of variables and constants separated by the mathematical operators, particularly only plus and minus. Okay, so if an algebraic expression has 2 terms, it is called as a binomial. If it has 3 terms, trinomial, and if it has more than 3 terms, multinomials. Okay, or I mean for more than 1 term, multinomial, but so binomial, trinomial, like that. Let us talk about binomial. It has only 2 terms. So let us look at this binomial. A plus B raised to 0. We know that A plus B raised to 0, anything raised to 0 is 1, so I'll get 1 as the answer. What about A plus B, the whole raised to 1? I'll get A plus B, right? What about A plus B whole squared? I'll get A squared plus 2AB plus B squared. Okay. What about A plus B whole cube? Now how can you find A plus B whole cube? Very simple. You can multiply A plus B with itself 3 times. So I will get this answer, A cubed plus 3A squared B plus 3AB squared plus B cube. Okay. So let us find A plus B whole power 4 then. A plus B whole power 4. So how can you find it? Very simple. I can multiply A plus B whole square with A plus B whole square, and you should get this following answer. You will get A power 4 plus 6, I'm sorry, not 6. You will get plus 4A cube B plus 6A squared B squared plus 4A B cube plus B raised to 4. So this is what you'll get. Okay, now let us observe few things, students, in these expansions of binomial expressions. Now you see here the power is 0 and there is 1 term. The power is 1 and there are 2 terms. The power is 2 and there are 3 terms. The power is 3 and there are 4 terms here, isn't it? 1, 2, 3, 4. And the power is 4 and there are 5 terms. 1, 2, 3, 4, 5. From this, can you deduce something? It's very clear that if when I write, let's say I want to write A plus B whole power 10, definitely this will have 11 terms. That is 1 more than 10, isn't it? So let's say if you want to find A plus B whole raised to 21, it will have 22 terms. So that is very clear. Okay, we can observe one more thing. I can write A as A power 1, B as B power 1, A power 1, B power 1, B as B power 1, B power 1 and A power 1. Okay, now what we see here is if we take only this term, the degree is 0, isn't it? If you take only this term, again the degree is, I'm sorry, if you take this term, the degree is 2, and if you take the second term, again the degree is 2, that is 1 plus 1. You add the powers, that will give you the degree. I mean, I'm saying that when you talk about, for example, the whole for this expression, the degree will be 2. But I'm taking one expression at one term at a time. In case if you get only one term, an expression with only one term, let's say a square, then the degree will be 2. Suppose if I take only one term, an expression with only one term, that is 2ab, I'll get again 2 as the degree. Again b squared, 2 is the degree. Now let us look at this. A cube, 3 is the degree. A squared b power 1, 3. A power 1 b squared 3, again b 3. So basically if you add the powers of the variables in each term, you're getting 3 as the answer. So same way here you're getting 4, a power 3 b power 1, again 4, a squared b squared 4, a1 b cube 4, b power 4. So from this what we can deduce is, if I want to find, let's say a plus b whole part, let's say 6. So definitely in every term the power of the variables will add up to 6. Now for example, here it starts with a power 1, here it starts with a power 2, here it starts with a power 3, here it starts with a power 4. So a plus b whole power 6 will start with a power 6, right? And the terms will look like this, like a power 4, b power 2, let's say a power 1, b power 5, let's say a power 5, b power 1, a squared, b power 4, and b power 6. As you can see, when you add up the powers, you will get 6 as the answer. So this is another thing that we have noticed. So we have noticed two things as of now. If the power of the binomial expression is n, then there will be n plus 1 term. That means if the power is 10, you will have 11 terms. And also every term, when we add up the power of the variables, you will definitely get n. For example, this 3 means, I'm sorry, this is 3 means the degree of each term will actually be 3. Or if you add up the powers of the variables in each term, you'll get 3 as the answer. Okay. Another thing you can notice is, like for example, here a power 1, and here there is no a. There's no a, right? A power 0. Here a power 2, and here a power 1, and there is no a. Here a power 3, a power 2, a power 1, no a. A power 4, a power 3, a power 2, a power 1, no a. So basically what you see is the power of a reduces by 1, right? The power of a cube, for example, in this expression, a cube, a squared, a, and no a. Same way, you can also notice the power of the second b, the second term, that is b, also increases by 1. In the first term, for example, here, let me take the last example. Here there is no b. Here there is b power 1. Here there is b power 2. Here there is b power 3. And here there is b power 4. Right? So this is again another thing that we have noticed. The only thing that we don't understand is, that we're not very clear about as of now, is the coefficients of each term. Right? So let me erase this and write it fresh. Okay, so let us look at the students. So if the power of the binomial expansion is n, then we'll have n plus 1 terms. Number of terms will be 1 more than that. And every term, when we add up the power of the variables, you'll get the same value as the n. I mean, n means here 1 or 2 or 3, like that. And also the degree of the power of a reduces by 1, and the degree of b increases by 1. For example, first term there will not be any b at all, and second term b power 1, third term b power 2, like that. Okay. Finally, what about the coefficients of each term? Now, if you look at it, here the coefficient is 1, again 1. Here it is 1, 2, and 1. Here it is 1, 3, 3, 1. Here it is 1, 4, 6, 4, 1. So how do we find those? constants. Okay, let us see. For example, I want to find a plus b whole raised to 5. Now one thing is clear, this expansion will have 6 terms because the power is 5, and definitely it will start with a power 5 and it will end with b power 5. Okay, so what will be the second term? Second term, as we saw, the power of a reduces by 1, so a power 4. Now we also saw that the power of b increases by 1. First term there is no b, so here there will be b power 1. And as you can see, the power of the variables 4 and 1 add up to 5 plus. The next term will be a cubed. Again, from 4 it becomes 3, and b squared. From 1 it becomes 2. Okay. Plus next term will be a squared b cube. Next term will be a power 1 b power 4, and the last term will definitely be b power 5. Okay. Now the only thing left is I know that here there will be 1, this is 1 and this is 1, so that's not a problem. But the only thing is I need to know what will come here, what will come here, what will come here, and what will come here. What will be the coefficients? Okay, now let us find out. Let me write a plus b raised to 4. Okay, so we have 1 here. I can write this 1 as 4c0, isn't it, students? 4c0 is nothing but, I have 4 here. I can write this 4 as 4c1. And I have 6 here. I can write it as 4c2. I have 4 here. I can write it as 4c3. I have 1 here. I can write it as 4c4. As you can see, 4c0, 4c1, 4c2, 4c3, and 4c4. Right? So, and one more thing you notice is that this one, that is this one, and the power of b will be same. 4c2 b power 2, 4c3 b power 3, 4c4 b power 4. Right? So basically, what it means is here I will get 5c0, which is nothing but 1. Here I'll get 5c1, which is nothing but 5. And here I'll get 5c2, which is nothing but 10. Here I'll get 5c3, again 10 is the answer. And here I'll get 5c4, so 5 is the answer. And here 1 is the answer. Right? So let me write, let's write one more time. So let me find the expansion of, let's say, a plus b power 6. So the first term will always be a power 6, and 6 is 0. I'll write it as 1. Then next term will be 6c1, a power 5, b power 1, plus 6c2, a power 4, b square, plus 6c3, a cube, b cube, plus 6c4, a squared, b power 4, plus 6c5, a power 1, b power 5, plus b power 6. Right? And of course, then you can find out what 6c1 is, 62, 63, 64, 65, and then write the answers. Very simple. So let me expand next binomial expression. Let's say I want to find x squared plus 2 by x the whole raised to 4. Let's say I want to expand this. Okay, as you can see, the power is 4, so you'll have 5 terms. The first term, this is actually a, and this is actually b, isn't it? Okay, the first term is a power 4, that means x squared raised to 4, plus the second term is 4c1, right? So 4c1, then the x squared power 4 will become x squared power 3, right? The power of the first term will reduce by 1, And now we'll have 2 by x here, 2 by x power 1 plus the third term is 4c2. Now x squared whole part 2 into 2 by x whole part 2. It will start increasing by 1 the second term, and the fourth term is 4c3 x squared power 1 into 2 by x raised to 3, and the last term will definitely be 2 by x raised to 4. So if you simplify, you'll get this answer. You'll get x power 8 plus, now 4c1 is 4, so this is 4, and you have a 2 here, so you'll get 8 times, this will become x power 6. I'm sorry, I'm not able to write it. So this will become x power 6, so 8 into x power 6 by x, this x will come here. So plus the third term is, and this 4c2 is nothing but 6, this is 6, and this 2 square is there, so that will become 4, so 24 times, this will become x power 4 into, and this will become x 1 by x squared plus, now the fourth term 4c3 is 4, and this 2 cube is 8, so 4 into 8 is 32 times x squared into 1 by x cube plus 16 by x raised to 4. So the answer will be, x raised to 8, plus 8 x power 5 plus 24 x squared plus 32 over x plus 16 over x power 4. So this is the expansion of x squared plus 2 by x whole raised to 4. Let's say I want to find 4x minus 3 the whole cubed. I can write it as 4x plus minus 3 the whole cube. So this is A is 4x and B is minus 3. So what is the expansion? Very simple. The first term will always be 4x cube. Now many students write like this. Please don't. This is incorrect. You should write a bracket here. 4x the whole cube plus second term will have 3c1 because the power is 3. So 3c1 4x raised to 2. The power of 4x will reduce by 1 into minus 3 plus the third term is 3c2 4x power 1 into minus 3 whole square plus the last term will be minus 3 the whole cube. So you'll get 64x cubed plus, it will be minus, you'll get 3 and you get 3 here and then 3 minus 3, so 9 and then 16. So basically it is 144, so minus 144 x squared plus, you'll get 3c2 is 3 here, 9 27, and then here there is a 4, so 108 x minus 27. So this is the expansion of 4x minus 3 the whole cube. Okay, let us general formula now. What is a plus b whole raised to n, where n is a natural number? Here the power is n, so therefore we know that there will be n plus 1 terms. Now the first term will always be a power n plus second term will have nc1 a power n minus 1 because the power of a reduces by 1, b power 1 plus nc2 a power n minus 2 b power 2 plus n c3 a power n minus 3 b power 3 plus, and the final term is b raised to n. So in this expansion you can notice that the nc1 and b power 1, nc2 and b power 2, like that, nc3 and b power 3. And one more thing, the power of a and b add up to n, isn't it? For example, here you have n minus 1 and 1, sorry, n minus 2 and 2, n minus 3 and 3, like that. Okay, and also n here and n here. The power of a and b add ups to n. Okay, now this is, I'll use a green one, T1. This is T2, term 2. This is term 3. This is term 4. You can notice that the term 2 has NC1. Term 3 has NC2. Term 4 has NC3. Right? So, suppose, what about term R plus 1? Right, let's not take term 1. Let's take term 10 now. Let's take term 10. Term 10 will have NC9, isn't it, students? Into, we know that this 9 will be the power of b, which is 9. Okay, now I need to know what will be a. Definitely the power of a and b add up to n, so a will be n minus 9. nc9 a power n minus 9 into b power 9. Good. So what if I want to find, let's say T21, then definitely you will have NC20 here. Power of b will be same as this 20, so 20, and power of a and b will add up to n, so it will be n minus 20. Right? Good. What about TR plus 1 then? What is TR plus 1? It will be NC R, isn't it? R plus 1, so 1 less than it R. So the power of b will be same as this, which is R, and since the power of a and b add up to n, I'll get n minus R. So NCR a power n minus R into b power R. So this is R plus 1th term. This is called as the general term of the binomial expansion. General term. So you might wonder, what is the use of this general term? Why are we doing this? Very simple explanation. So, okay, let's say I want to find, let's say 3x plus 4, that is whole power 20. Let's say I want to find the 10th term. Okay. Now you don't have to expand all the terms to find actually what, to find the nth term. So what you can do is, here a is 3x, b is 4, and n is 20. So I can write the general term TR plus 1 equal to NCR a power n minus R b power R. So which is nothing but 20 CR. A means 3x, a is 3x, so 3x power 20 minus R into b is 4, so 4 power R. So when I write, I need to find T10, 10th term, so put R as 9. So I'll get T10 equal to, because when R is 9, R plus 1 will become 10. So 20 C10 multiplied with 3x the whole raised to 10 multiplied with 4 power 10. So if we simplify this and find the answer, so basically this general term can help you to find a particular term. If you want the 10th term, or if you want the 5th term, or if you want the 4th term, any particular term that you want, you can find using this general term. Okay, let's say in this expansion I want to find the 5th term. So I'll write here A is x, b is 2 by x, and n is 10. So you'll get TR plus 1 equal to NCR, that is 10 CR a power n minus R, so x power 5 minus R into b per r, which is 2 by x per r. So I need to find T5, so I'll write R equal to 4. So I'll get T5 equal to 10C4 multiplied with x bar 5 minus 4 into 2 by x per 4. So you find 10C4, you shall get, so I'll get 2 power 10 multiplied with x multiplied with 16 by x power 4. So the final answer is 3360 divided by x cubed. So this is the fifth term. So in this expansion we know that there will be 11 terms. 3360 by x cubed will be the fifth term when expanded in descending paths of x. That means the first term will have x power 10, second term will have x power 9, third term will have not x power 10, I mean we need a x power 10 into, yeah, first term x power 10, second term x power 10 into this 10c1 2 by x, so it will become x power 8, x power 9. Third term will have x power 8 multiplied with 2 by x the whole square, so it will become x power 6, like that. So descending paths of x, so this will be the fifth term. Okay, so this is it, students. So what I'll do is in the second video we will solve more problems using binomial expansion. Thanks for watching this video.